All right, guys, like we said, we're just gonna continue where we stopped. So here we're just gonna look at number pattern as we move to trig and also functions. All right. So without any waste of time, we're just gonna run as quickly as we can. Let's see what the question has for us. The sequence 3, 9, 17, 27, it is a quadratic. My dear people, here is your keyword. It is a quadratic sequence. What do we know about the quadratic? It is two difference. All right. So let's see. Just gonna compartmentalize my board for the sake of space so that we can have a nice presentation. Wait, it doesn't write the way I want. Let me do the adjustment. Let me do the adjustment. Awesome. There we go. All right, what do I have? I have a quadratic, okay? The first term, it is 3. The second term is 9. Okay, 70 and 27. Since it's a quadratic, I'm just going to get my first difference, which form the arithmetic. 9 minus 3, that will be 6. 70 minus 9, that will be 8. 27 minus 70, that will be 10. Okay, that's my first difference. I'm just going to run to my second difference. 8 minus 6, that's 2. 10 minus 8, that's 2. All right, it's now satisfied the condition that it is a quadratic. So can I get A, B, and C? We're going to say 2A equals to 3A plus B, which will give you 6. A plus B plus C, which equals to the first term. All right, let's see now what the question is up to. Write down the next term. Okay, this is my T1, T2, T3, T4. All right, are you aware that I'm gonna get 2 throughout because it has to be the constant? Okay, check something. Let's look at the trend here. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2, that will be 12. 12 plus 2, that will be 14. Okay, I want us to work up and down forth. So 3 plus 6 is 9. 9 plus 8, 70. 70 plus 10, 27. All right, so it means 27 plus 12, all right, will give us 39. Okay, we can even get the other one, although they need the next term. All right, so what can we do? It's easy. 39 plus 14, that will be 5 there and 3. Awesome. Awesome. I hope you can see the trend. Okay, so we are done. They needed this. We even went deeper. All right, sweet. Write down an expression of the nth term of this sequence. Okay, now examiner wants Tn equals to an squared plus bn plus c. All right, let's see. We need to get a, b, and c. How do we get a? 2a equals to 2. Divide through by 2, a will give you 1. 3a plus b will give you 6. But I know a is 1. I can quickly get my b. And b will be 6 minus 3, which will give you 3. Awesome. How do we get a? A plus b plus c will give you 3. What is a? We got it as 1, B 3, and C, we are looking for it. 3 plus 1, that will be 4, plus C will give you 3. Take it to other side. C equals to 3 minus 4, which will give you negative 1. We are done, child. So Tn will be n squared plus 3n minus 1. You're good to go. You are good to go. Let's run. The second question says, what is the, oh guys, let's learn to interpret. What is the value of the first term of the sequence that, right, I have my keyword. The value of the first term of sequence that is greater than, all right. So I'm looking for a particular value. that, hold on, I'm looking for a particular value such that our Tn will be greater than 269. I hope my interpretation makes sense. All right, what is Tn? It is the n squared plus 3n minus 1, which is greater than 269. Okay, I see it needs a little bit of algebra here. Okay, I'm just gonna take it to this side, change the sign, become negative. I'm gonna group like term minus and minus, that will be minus 270, which will be greater than 0. Okay, find factors here. All right, which numbers can I multiply to get negative 270 such that when I add I get positive 3? All right, factors. I know you say, what is this guy doing now? You'll see something. Okay, let me do my tricks, let me do my magic here. All right, and that this doesn't help. Okay, if I have 3 and that will be, I have 25 there, and that will be 80, that will be 50. All right, sweet. I'm done with my factors. I know you've been asking yourself, what is the guy doing? All right, you can use a quadratic formula to get the factors still acceptable. All right, so I have n, and I got 80, I got 50. Okay, this has to be positive, this has to be negative. So n plus 80 is greater than 0, or n minus 50 is greater than 0. All right, n is greater than negative 80, or n is greater than 50. This one cannot be the solution. N has to be positive. But check something. N should be greater than 50. I'm looking for the first term value. Okay, so the first integer. All right, let me try to squeeze it here. The first integer that is greater than, let me make a note, the first integer that is greater than 50 is 60. Okay, I hope you get my interpretation. So n equals to 60. All right, so I'm looking for the first integer that is greater than 50, which is 60. So can we then substitute and get the answer done? Tn equals to, oh, I'm looking for T60 now. My n is 60. All right, that will be, can I try to squeeze it in where? My space. Let me try something here. I wanna try to squeeze everything on a board. Oh no, oh no, oh no. My letters have been removed. Okay, it's okay. Let's do it here. T60 will be 60 squared plus 3 times 60 minus 1. You can use a calculator. That will be 303. 10. We are done, child. Good to go. All right. So there are common questions that they can ask you here to find the maximum. All right, let's just have a crash course. We are just revising. They can ask you to find the maximum or minimum term value. Okay, term value of quadratic. How do we deal with that? All right, allow me to assist. Allow me to assist you over here and check the beauty of maths. And check the beauty of maths. Remember Tn, it is given as an squared plus bn plus c. All right, I hope you're with me. So this is the same thing as y equals to ax squared plus bx plus c. Let me give you a note. A quadratic pattern, or sequence rather, sequence behaves, okay, or can I say behave like a quadratic function? Okay, quadratic functions. I hope you get what I mean. They behave the same. Okay, If A is greater than 0, the possible shape that I'm gonna get will be like this happy face. If A is less than 0, I'm gonna have the maximum. All right. So here it is the minimum, and here it is the maximum. Wait, black child, let's check something. When we talk about minimum and maximum, we are basically referring to the turning point. Okay, turning points. We are referring to the turning points. All right, we are referring to the okay, we are referring to turning point. How do we get the turning point in maths? X equals to negative b over 2a. But yes, this is number pattern. Instead of x, I'm gonna put n. N equals to negative b over 2a. All right, I hope you can see this. And then, my dear people, n should always be greater than 0, guys. N should always be greater than 0, where n is the element of the integers. All right, so we are now maximizing. Maximum or minimum basically refer to the turning point. I hope the explanation is so helpful and handy. Let's look at this other. I still remember the unique pattern I ever solved. Let's check something. It was 0, 17, 32. Okay, let's find our first difference. 17 minus 0 will be 17. 32 minus 17, that will be 15. All right, let's check something. 15, 70, that will be negative 2. Can I get my Tn? Okay, I'm going to use my formula. 2a equals to 3a plus b equals to a plus b plus c equals to, okay, we can now get a, b, and c. Check something. 2a equals to negative 2. What is a? Negative 1. All right. 3a plus b will be 17. So this will be 3 into negative 1 plus b, that will be 17. What is b? B will be minus 3. Take that aside, become positive. 17 plus 3, that will be 20. Okay, a plus b plus c will be 0. I hope we have all the factors. Negative 1 plus 20 plus c equals to 0. Take it to other side, or anyhow you want to do your maths will be acceptable. So minus 1 plus 20, that will be positive 19 plus c, and that's 0. C equals to negative 90. Take it to other side, changes the sign. So now Tn equals to AN squared plus Bn plus C. Wait. What is A? Negative n squared plus 20n minus 90. You can see the value of A is negative. All right, it's negative. So we have the maximum. It's at maximum. Okay, that's the maximum. When a is negative, that's the type of graph you're gonna get. So this is called the maximum. How do we get the maximum term? N equals to negative b over 2a, and that will be negative into 20. All right, that will be 2 into negative 1. Your answer would be, am I correct? Yes, that will be 10. Okay, allow me to do something. I want to prove this to you. You will see. You will see how am I doing things. You will see. I'm just going to drag it. Also this, I want to move it to this side. I want to move the whole of this. I want to do something nice for you. Oh no, it doesn't want to move. Once again. Wait. I'm trying to drag this to other side for the sake of space. Sweet. All right. So what does it implies? It tells you that the maximum of this graph is 10 here. So I can actually prove that this is correct. Can we please find T9, T10, and T11? And what I can predict is that T9 and T11 will be the same. I will explain what am I saying. All right, this is T10, don't forget. If we try to find T9, let's just get T9 first and we'll see where are we then going. All right, let's try to get this and see something. Where's n? I'm gonna put 9 and this will be negative into 9 squared plus 20 times 9 minus 19. For the sake of space, I'm just gonna do what I did previously just for the sake of space. I want my presentation to be nice, looking good, and have a space. All right. Apologies. I just awesome. So if we use a calculator, we actually gonna get 8. And then for T11, that would be negative 10 squared plus 20 times 10 minus 19. And that's actually 10 times 20, then negative, that will be 81. Let's do for T11 together. Negative 11 all squared plus 20 times 11 minus 19. All right. And what are we gonna get? 20 times 11, that's 220 minus 19, and there that will be 80 as well. Check something. T9 is equals to T11. How is that possible? Okay, look here, black child, and see the beauty of maths. And see the beauty of maths. Remember, here is T10. Let me use a different marker for illustration. That's T10. It's at maximum. So T9 is somewhere here, and T11 is somewhere here. Can you see that here? I love this. Is 9, 10, 11 is going down. Here is maximum. So can I say this is a point of or line of symmetry? Whatever happened to the left, it is replicated to the right. All right. Okay. That's a function, a understanding of functions. Oh no, my body is lagging. So it means whatever happened to the left, it is replicated to the right. So this is the same as this. Okay, that's a deep understanding of function. Whatever happened to the left, let me just make it as a note. Just gonna draw the cloud for the note. So whatever happened to the right is replicated. Okay, replicated to the left. That's a line of symmetry. Okay, this is a line of symmetry. Let me just make it as a note. This is a line of symmetry. Okay, sweet. I hope you now see this and you are loving the explanation behind all. So are we done with the questions? Let's see. All right, all question answers. I even went furthermore for just explanation. All right, let's move now. Guys, always to master number patterns, read the statement line by line with interpretation. Don't just read like you're reading a newspaper, right? You're gonna miss some important notes. Read with understanding. Okay? Read with understanding. Check how I'm gonna tackle this in 2 minutes. You will see. The first two terms of an arithmetic series, which is A. Where's A? Okay, I see. It is the arithmetic. And a geometric series to infinity, which is B. Okay, that's your are the same. Okay, they said they are the same. We can see negative 2 plus a, and on b we have negative 2 plus a. Write down in terms of a, meaning the answer should have a as an answer. All right, the part of the equation should have a. Write down in terms of a the third term. Wait, they mentioned something, the third term. Let's learn to acclimatize the third term, T3 of geometry. All right, just gonna get everything done. 3.1.1. Since they mention geometry, the first thing that comes into my mind, it is the ratio. And I have this other t-shirt, you're gonna love it. It says, I wanna wear it one day. The difference between arithmetic and geometric is ratio. Okay, it's mercantile, make learning easy and fun. All right, the difference, I'm just gonna put a cloud to show this is fun. It's fun time. Do I have a sticker for fun time? Let me check. I do not have it, but okay, one day I'm just gonna have my stickers. But let me check here. In my resources, I won't find it. Let me, it's gonna waste our time, but it's fun time. Here's how I read my merchandise. Let's try to drag it down for clear and clarity. They're moving together. Why? It's okay. I can see they don't want to move separately. It's okay. So this is how I'm reading my merchandise. The difference between arithmetic. Wait, the difference, let me use a white marker for clarity. The difference between arithmetic and geometric is ratio. I think this explains everything. It means arithmetic, it is difference. Geometric is ratio. Okay, merchandise learning made easy. So how do we get R? R equals to T2 over T1. So can I get my R? What is T2? It is A T1 negative 2. So the answer is negative A over 2. All right, I see I'm just gonna need a space. Just gonna drag this over for the sake of space. Move, stop wasting my time. Time is expensive. All right, sweet. Let's see. I know my R now, but they said T3. Do you still remember our multiple common ratio? T3 will be A times R to the power of 2. Do I know A? The first term, yes, it's negative 2. Do I know the R? Aha, I know the R. It is A over negative 2 all squared. I believe you can now do algebra. That will be negative 2 times A squared over 4. And then you can actually break this like this. That's how I like to do my maths. 4 can be written as 2 times 2. And check something, this and this, they will cancel. What am I left with? I'm left with negative A squared over 2. I am done. They said in terms of A. All right, they said in terms of A. I'm just going to divide my board for space. I'm just going to divide my board for space. For space. All right, for the sake of space. All right, but I would like to remove my merchandise because I'm already done with it. Okay, allow me to do this. I want to remove my merchandise. Learning made easy. I think I should get a proper page or fresh page rather. All right. Okay, I just save it to the other. slide because I want to move. It's blocking my view. Let me try to cut because it doesn't want to move up there. All right, sweet. Let me clean my board. I love the professionist to an extent. All right, write down the third term if it's arithmetic. When it comes to arithmetic, let's see. What do I know? Common difference. How do I get common difference? D equals to T2 minus T1. So what is T2? It is A minus negative 2. I did a bracket. Whenever you're subtracting, please do a bracket. That will be A plus 2. But they said the T3. So T3, it is A plus 2D. I hope you know where I got my formulas. This will be A plus 2 into A plus 2. Let's do math. That will be A plus this time, that will be 2A. All right, that will be 4. Adding like terms together. I hope I'm not doing any single mistake. That will be 3A plus 4. But then wait. Do I know the first term? Yes, it's negative 2. Let's substitute so that we don't play around with fire, okay? I thought maybe it's unknown. It is known. It's negative 2. So I'm going to put it there. Negative 2, negative 2. All right, I'm going to have negative 2 plus 4 plus 2a. I hope you see my mess. This minus this, I'm gonna left with 2. So I'm 2 plus 2a. I hope everybody's okay. So that is T3. It's all about maths. It's all about maths. Let's move. We have all right, I think it's a continuation. All right, let's see. Just gonna compartmentalize my board. All right, let's see. The sum, I like to, you know, annotate the sum of the first 3 terms of arithmetic series A is the same as the third term of geometric series, which is B. Wait. Okay, wait. The sum. So the sum of the first 3 terms, so T1 plus T2 plus T3 is the same. In math, the same is equals to the third term of geometry, T3 of geo. And this one is an arithmetic. All right. Excuse me. Let's see. Do I know the T1? Yes, I do. Is negative 2. Do I know the second term? That's A. Do I know the third term? Yes, is what I got recently. Let's move. Just gotta move to the other slide and see what we have. Is 2a plus 2. All right, I hope you see 2a plus 2. Wait. Okay, that's 2a plus 2. The third term is 2a plus 2. All right, I have a plus 2a plus 2, which equals to the third term of geometric. Do we know the third term of geometric? It is negative a squared over 2. All right, negative a squared over 2. Let's just add everything together. Negative, let me use another color. Negative and positive. So I'm left with a plus 2a. That will be 3a equals to negative a squared over 2. Can we do cross multiplication? 6a equals to negative a squared. Guys, do not divide. I'm going to make it as a note. Do not divide. All right. Every time you see squared, it means you should have two solutions. Whenever you divide, you are losing a solution. It means you should have two solutions to not divide. When you divide, basically you're losing the solution. So I'm gonna have 6a plus a squared equals to 0. I can take a as a common factor. I hope you see my maths. So a equals to 0 or a equals to -6. But check something. A cannot be 0. Do you know why? I cannot have 0 as a ratio. Check something. Check our ratio here. It is, okay, if A is 0, it means I'm going to have 0 divided by 2. I cannot have a ratio being 0. So we have to restrict. A cannot be the solution. So A is not equals to 0. The only solution that I have is -6. All right, is -6. If A equals to -6, they're actually selling themselves. They are selling themselves. All right. If A is -6, determine if the geometric series will converge. Wait, let me do this. I know what I'm doing. Checks what I will do. Oh no. I wanted to move this aside. All right, it's okay. Wait, let me do this. Aha, it's now easy. I want to have a space. Awesome. I wanted to create a space. Let's see. I'm just going to clean this. All right. So what do we know? If A equals to -6, determine if the geometric series will then converge. Excuse me, what is the rule of convergence? The rule for convergence says R should lie between -1 and 1. Okay, so let's see. Can we get our R? R is T2 over T1, and that will actually be A over -2. But they said if A is -6, so -6 divided by -2, which will be +3. You see, it doesn't lie between here. So we're gonna say no, it will not converge. Why? Because R is greater than 1. It will not converge. For convergence, okay, we are just going deeper. For convergence, R should lie between -1 and +1. So if it's above this, it will not converge. I hope the explanation is been well, making a good sense out of it. All right, let's see if we still have other questions. All right, okay, I see this. I see. Let me divide my slide. I thought maybe we are done, but it's okay. Let's move. The sum to n term of geometric is given as, all right, Sn equals to n over 2 into 5n plus 9. Calculate the sum of the first 23 terms of the sequence. Okay, I think that's easy. Easy pie for every living soul. Why I see and I put 23. As 23 will be 23 over 2 into 5 times 23 plus 9. And that will actually be 14 26. 26. Done. 3 marks for every living soul. Hence, calculate the 23rd term of the sequence. They want the term, okay, of the sequence. They didn't say the sum, so they want the t. Okay, this is the application. Then this other formula, it is not on the formula sheet, hence application. It says S n equal my, okay, this is the application, my child. It is the application. All right, something now. Do I know this is the S23 equals to S? N is 23. 23 minus 1 would be 22 plus T 23. We are done. But check something. Do I need 3 years? 40, 26, which will be S22. We can actually calculate that would be 22 divided by 2 into 5 times 22 plus 9, okay, plus T23. Okay, let me just take it to other side so that I can do my maths without a calculator. Awesome. All right, just a moment. Okay, sweet. Let's see something. 40, 26, which will be 11 divided 22 divided by 2 is 11. I'm already telling you the answer. Okay, that will be 11 into 5 times 22. That will be a 110. I believe it's 110. 110 plus 9. All right, I hope you can do maths. That will be 110 times 11. That will be 9 there. That will be 310. Okay, you can actually confirm using a calculator. You can pause the video, confirm, but for the sake of time, I'm just gonna use my crazy maths. That will be 1309 plus T23. You can get T23 easily. T23 will be 1426 minus 1309, and that will be actually 8 minus 1 will be 7 and 1 1. Okay, done. You are done. Just crazy extent, but please, the formula is not in the formula sheet. It is not given. Let me just make a note. It is not given on formula sheet. It is not given. It is the application. What do you have to know? It's application. Apply it. All right. The last one. Can I just get this on a fresh slide? Let me see if I can get the last one. Hold on. I want this on a nice and fresh. Oh, the question is gone. Okay, wait. All right. I will appreciate if I can get this on a fresh page. I will appreciate if I can get this on a nice page. Okay, remember, it's only me in the class, just a bishop presentation. Oh, I know. Wait. All right, I'm just gonna drag it a little bit up and zoom it out for clear feasibility. Is blocking my time, but not important at all. Let's see what I have here. Just gonna divide my page always for the sake of space. All right. If x is a real number, I'm just going to annotate. If x is a real number, show that the following sequence cannot be a geometric series. All right. They mention a geometric. I'm going to keep on using my religious system. I'm talking about the ratio. How do we get the ratio? T2 over T1 equals to T3 over T2. All right, what am I given? I have 1, x plus 1, x minus 3, T1, T2, T3. Can I just work with my ratio? All right, what is T2? X plus 1 over T1, which is 1, equals to T3. X minus 3 over x plus 1. What do you want us to do? We can do crazy maths. This time I'm going to have x plus 1 times x plus 1 multiplied by x minus 1. I can actually, this is x my, okay, 1 squared, which equals to x minus 3. Okay, let's just try to expand. Let's just try to expand. Okay, let me teach you something here before I want to do my crazy stuff. This, I like to say first squared plus 2, okay, first times last squared. Okay, learn some little trick. What is first squared? The only first term that I have here will be x squared. First squared will be x squared plus 2. What is first times last? This is my first, this is my last. It's gonna be x times 1. So that will be x plus, what is the last term? It is 1. So it's 1 squared. So basically that is x squared plus 2x plus 1. I hope you learn this trick. Okay. Learn fun things without wasting time. F for first, let me put the keynote. I like to do crazy things. F for the first term. Oh, I'm running out of time. L, it is the last. So if I have A plus B all squared, so this is my first and this is my last. Okay, I hope you are learning some quick tricks as we are moving. So wait, what do I have? I have x squared plus 2x plus 1, which will be equals to x minus 3. Let me take it to other side. Okay. All right, let's do math. That will be x squared 2x minus x. That will be, am I doing the right thing here? Okay, that will be plus x. 1 plus 3 will be 4. Okay, we cannot find factors here. I don't see a solution. All right, let me do, you can use a quadratic, but I just want to do something crazy. How do we prove if there's no solution? Just gonna duplicate my slide for the sake of space. All right, let me do my, how do we prove if there's no solution here? Use a quadratic, you're allowed to do that. But I want you to be advanced, a little bit advanced, so you see how maths can be done. I'm just gonna go out with the equation. Wait. I'm trying to get this alone. The time is out. I'm left with 2 minutes. Should end at past 11. I'm just left with 2 minutes. All right. We could go for function, but it will be on the next session. Please. All right. Doesn't want to move. What's again? All right. Before it wastes my time, how do we prove if there's no solution? I'm just going to use my delta. B squared minus 4AC. And what is my B? It will be 1 squared minus 4 into 1 times 4. And that will be 1 minus 60, which is negative 50. So my delta, it is less than 0. So what does it mean? It means that the roots are unreal. Unreal. So there is no solution. No solution. I hope you see how am I bringing my nature fruits for your own saving. We can use a quadratic. Let me use a quadratic because you are used to that, but I just want you to see how beauty and how easy math problem can be solved. Hence, Bishop presentation here. All right. I want to cut this. I'm so worried it doesn't want to go all along at the same time, but it's okay. I want to awesome. Okay, let's see something. You can use a quadratic. Okay, I have x squared. My pen, let me get it clear. All right, time is up, but my pen is now leaking. I don't know what could be the problem. My pen is lagging. It is delaying my process. Okay, time up. All right, let me try to run. We have the x squared plus x plus 4 is equals to 0. We can use quadratic. X equals to negative b plus or minus the square root of b squared minus 4ac. Everything divided by 2a, right? I see I've done right here, but it's still delaying. It's okay. Let's just be a little bit patient. We are closing the class. Can we then teach method of substituting? X is equals to negative 1 or that to be 1 squared minus 4 to 1. X equals to negative 1 plus or minus, so that would be 1 minus 60, that will be minus 50. You can see there's no solution, all right? And that will actually be minus 50 over 2. So there is no real solution. Don't be tempted or be scared when you see such kind of question. It is possible for us not to have a solution. So guys, this is Bishop signing out. Goodbye, keep well and stay blessed.